when a bunch of people are gone. Okay, welcome everyone. So I'm going to talk briefly about 12-2 um, vector operations, okay? Courtney, how are you today? Awesome. You say that with such vigor. Gusto. Mucho gusto. Okay. So to begin with, I want to talk in real general terms, and then we'll do some specific examples. If you have vectors, well, to begin with, since Mr. Hale is here, what makes a vector, Madeline? What makes a vector? Tanner, Lifeline? Okay, you're right, but let's try to generalize it a bit more. A vector has to have two aspects to it. Magnitude is one, and then Tanner, direction. And we should point out that a vector can be represented in a lot of different ways. It can be a velocity. In other words, I drove to Ricriol to be amazed, and that was north at 40 miles per hour, right? Because Ricriol is an amazing place. North, 40 miles per hour. What's my direction, Trevor? What's my direction? North is my direction. It reminds me of Jeopardy on Saturday Night Live, right? Right? You know, on Saturday Night Live, they have that Jeopardy skit, and they say, the answer is 7. And everyone keeps getting it wrong. I don't know. I think you have to be a teacher to fully appreciate that, Anyway. Yeah. Okay. North is the direction, and the magnitude would be 40 miles per hour. But there are other ones that might be different, like Mr. Craven's air rifle. You've seen that thing he's got. It poof. It throws air at you. And if he points it at Jolynn, that's direction. And if he poof, shoots it, this rush of air, that's a magnitude, right? That air has some kind of velocity, even though that's different, and direction. And if I come unglued, and if I punch Jamie, I just lose it. And if I punch Jamie, my fist goes like this, and that's a direction. And then what's the magnitude? The amount of force that I strike her with. Not that that would ever happen. I'm just this close, Jamie. Anyway. Okay, so what else, Mr. Hale? What are some other vector things? Is there any kind of momentum? Okay. And there's probably more than we're not. I was thinking about things like sound, but sound doesn't really have direction. It's omnidirectional, so that really wouldn't be a vector. Or like earthquakes.
Waves do, they have direction that the wave's heading and the wave from itself.
Okay, there might be ways to look at it like that, but I'm not an expert on that stuff. But I like it. I like applied math, but I'm really more math. But I think what's the point of doing these vectors if you can't attach them to something? Okay, so anyway, one thing that we can do with vectors then is add two vectors. And we touched on this a little bit the other day when we had the airplane flying and the wind was acting upon it. Okay? So if we have some vector, and I don't know why they use U and V for vectors all the time, but they do. You see that all the time. So you have the tail of the vector and the tip of the vector. Sometimes you'll hear that language, but I just look at the start of it and the arrow here. They have to have a direction. So if a vector was doing this and then another vector was doing this, what would you expect the resultant vector to be? Tyler? Exactly. Very good. The one that would connect the two, which would go from here to here. I don't know. What's after V? Call it W. I don't know. Yeah. U plus V equals W. And that is really makes total sense. Okay? Everyone does fine with that. Well, most of the time. The one that messes, any questions with that? Courtney, question? Okay, the one that messes with people's heads is this one. There's one. There's another. I need an arrow for direction. So there's U. There's V. Now, what if I want to go U minus V? This is the one that messes with people's heads. And remember, we have directions, so we've got arrows going this way. What if I want to go U minus V? Now, quit looking at the book. Think about this. Just think about this. Okay, I want you to understand this, Tanner, from a more of a natural standpoint. I'll give you a hint. Okay? 8 minus 5 is the same as 8 plus negative 5. Jamie, you want to take a stab at it? You know, you are making so much nonsense that might work, actually. Okay, so you're saying take the vector going up, like this, that guy, and then what are we going to do with it? Which way? Okay, straight down. Let's change the arrow. So how would you describe this vector here, this dashed line? Branson, how would you describe this one? Opposite of what? Exactly. That is the opposite of E. It's evil twin. So now if I say U, I should probably go red. If I say U plus the opposite of V, pardon me, U plus the opposite of V, what would that one look like? Well, it would go like that. I should get rid of that. It wouldn't have that. Wouldn't have that. It would have the arrow there. And that is so true, and that's exactly right. So, nice job, Jamie. That's good. So we can have a vector here. We can have its evil twin, the opposite of the vector, going the opposite way, same magnitude. Okay? Well done. Item next. And this part, you've done it all before. You just haven't thought of it maybe as vectors. Okay? So we need, oh, no we don't. Where's my content when I need it? Mr. Hale probably stole it. This will work. Get out of there. Evil little, yeah. Okay. So, let's play around with this a little bit. So, we could have one vector going like this. I can't do that. It doesn't have arrows. Gotta have arrows. We could have one vector going like this. We could have another vector going like this. Let's put some coordinates on this. Let's say that this is 0, 0 down here. Okay. What are the coordinates right there, and right there? Just ones. It's fine. One, 5. 9, 1. 11, 6. Okay? So, if you want to find the vector from 1, 5 to 11, 6, how do you do that? All right, we made a friend. And then what's the horizontal distance? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She is right, as usual. What's the vertical distance? Trick question.
1.
Thank you. It's 1. Now, okay, you believe me? You hear me now and believe me later?
Are we supposed to make friends sooner or
Well, it's fine. So we had the coordinates 1, 5, and 11, 6. Now we don't have a drawing at all. It's a crisis. We can't make a friend. Everyone hates us. Jamie says we can go x sub 2 minus x sub 1. And then what? Now you're reading your book again, Jamie. That worries me.
Well, like, I was going to say that to begin with, but it says squared. I wasn't going to say squared. Why do you have to square it?
Well, if you have a triangle like this. No, it doesn't, Jamie. Be good to yourself. Be good to yourself. You're so right. Just about half of mathematics seems to come back to the Pythagorean theorem, I swear. No, everywhere. We were doing center of mass the other day, center of gravity, centroid, whatever, right? And I was thinking, really? Yeah, it's everywhere. Okay, so x2 x minus x1 squared plus somebody other than Jamie. Jonathan, what about you, man? Who cares? I'll pick on you anyway. Distance formula between these two cats. X sub 2, x sub 1, y sub 2, y sub 1. All right, Jonathan, you're up. It would. And then what? Well, what's missing? How are these two different? Squared. Okay? And then what's missing? Branson. Yeah, square root. And then what's missing? Daniel. Nope. I know. That's why I'm picking on you. D equals. So you just did the distance formula, but you don't have to memorize that. You just have to remember it's a triangle. Not any kind of a triangle, but a right triangle. And if you have a right triangle, well, A squared plus B squared equals C squared. All you're doing when you go x sub 2 minus x sub 1, guess what? You're going to get 10. Y sub 2 minus y sub 1, you're going to get 1. And you're squaring them, and you're taking the square root, you're finding the distance. But it's really, really just drawing a triangle and finding the Pythagorean theorem. So don't freak out like you have to memorize that. It's really just the Pythagorean theorem. So now we have D equals the square root. Madeline, you're up. Mm-hmm. Mm-hmm. Okay, 5 minus 6 quantity squared. We get D equals the square root of 10 squared plus 1 squared. D equals the square root of... Well,
It doesn't really matter.
okay. All right, we're going to talk about that. It's negative 10 squared, and it's negative 1 squared. And you're right. When you square them, they become positive.
I just say
No, I would.
different steps.
And I would. I appreciate that, Daniel. Okay, so we get the square root of 101, which is about 10 point-ish. Okay? Reasonable answer? Yeah, it's going to be just a little bit longer than 10 because that's so small. Now, so Daniel's religion does not allow him to start with 1 because it's too selfish. Okay? So Daniel's religion says D equals the square root of 11 minus 1 squared plus 6 minus 5 squared. Oh, hey, it's the same thing. So the moral of the story is it doesn't matter which is x1 and which is x2. But the main thing is if you start with this one, then you have to start with this one. You can't mix and match. But it doesn't matter on which end you start. And that's nice. Okay? So then we have that distance, 10 point something. 10 point how much? 10 point whatever-ish. That's fine. Now, what if we want a direction as well? What about getting this little angle in here? Ty, what about it, man? You could do law of cosines because you know all three sides, but that's a little bit of a 12 gauge when it's a bazooka when a bazooka at a tea party when a daisy pellet gun will do. I don't know. So Jamie, cousin Jamie Ty says that you know that it's a right triangle is her hint. So what could we do? Cousin Jamie said that 1 is what side, Jamie? She said that's opposite. And she said 10 is adjacent. You could say that tangent of the green blob equals opposite over adjacent equals 1 over 10. So the measure of the green blob equals what, Ty? Office human, how are you? Okay, far out. Not here. Zach's not in the other room, is he? He's not here. Zach Myers. Okay, thank you. Not here. Equals arctan 1 over 10. What'd you get, Ty? I fear that you're in radian mode, so let's go degrees for this. And we love radians, but... Is it that small? It should be a little bit bigger than that.
Make sure you get
That's 110. Take the arc thing.
There we go. 5.71, about, I should say. 5.71 degrees. Jamie, stay with it, please. If you want to talk, you know, you can go talk, but I cannot compete with you two. You're way more cool. Okay? So I'm almost done. So we can say, and we've been doing this stuff forever. It's just right triangle trig, but now we're looking at it in a different way. We're saying, oh, the vector of this line is, its direction is 5.71 degrees, and its magnitude is 10 point whatever. Different way to look at it. But wait, there's more. What if I was looking at this and I wanted to express it in terms of just vector addition? So this is negative, what, 1, 2, 3, 4. Negative 4. This is 1, 2, 3, 4, 5, 6, 7, 8. Okay? Just think of it in rectangular terms. This one's negative 4, 8. This one is... What's this one? Who haven't I picked on? Alexis, how are you? Good. What about this triangle here? What's it going to do? How long is this side? 2. Okay. This one's 2. How about this side? 5. Yeah. So think about this now. If I add negative 4 and 5, Tanner, because I started here and I went down 4. I could have done this, Tanner, and that's a good question. I could have started here, gone this way, but since my arrow was going this way, I thought I'll start here, go down 4, and then right 8. And in direction matters here, because remember with vectors, I have an arrow down here. And I have an arrow here. Okay? So I have to start here, and I go down 4, which is negative. I go to the right, 8, which is positive. Okay? Now that's important. Now, on this one, I have to start here and go here, so I go to the right 2. Mackenzie, is right positive or negative? Positive. So it's positive, positive. And now when I combine these guys, negative 4 plus 5, what do I get? 1. When I combine 8 and 2, both positive, I get 10. Same thing. So, like in your book, they have all this crazy notation, A plus C and B plus D. All they're doing are completing these triangles, so don't get freaked out by all that notation. Okay? But it's easier to see here than when you don't have a drawing and everything's algebraic, but you'll be okay. Questions? All right, I think I've talked enough. Bastante. I'll give you the remainder of the period to work on that assignment from 12-2.